Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to walk through step-by-step designing the headlight for our GPZ series. So as mentioned in the previous video when we went over this, as I was designing this, I went through a couple of different iterations and different design ideas as we started the process and evolved into something completely different than I had intended. Now that happens with design. Sometimes you have an idea, you kind of throw it out there, see how it looks, make some adjustments, and eventually you just have to scrap it and start over. That's part of it because not everything pans out. Either aesthetically doesn't look right, or the geometry isn't working right, or maybe in 3D you just don't like the way it looks as well as you thought you did. So in this video, we're gonna kind of skip the initial design process, some of the stuff I scrapped, and we're gonna jump right into the headlight that we have here. Now, because we are designing it in this video, it is going to be different than the part we have here just slightly, but the process is still the same. We still want to understand how we got to this point, even if it is going to be slightly different. And the reason I do videos this way, I film and I narrate them at the same time rather than pre-planning them, is because I think that the challenges we run into and the decisions that are made along the way are really the important bits of this. It's not really clicking and picking and step by step on making this exact part, but understanding why we do what we do throughout that process. So with this part, the first step was taking the original KTM headlight and scanning it.
So with a part like this, we have to use some prep spray because it's got shiny chrome plastic on the back and a clear lens on the front. There's just no chance in us doing it any other way. So once we prep it, then we can get started scanning. Now I'm only going to really talk about the Metro X here in this instance because that's what I used to scan the version of the headlight that we're using in Fusion. And basically the process is to use full field mode here, which is essentially an upgraded RevoPoint Mini 2, and get as much of the lens as you can while wrapping around the side. Now, this is important because when we go to merge multiple scans together, we need to make sure that we have some reference on the back side or the side of the headlight that can be used for those references. Now, this is a little bit tricky, especially with trying not to use too much scan spray. This is the disappearing stuff that lasts for 2 to 4 hours, and I kind of rushed it a little bit. So throughout the process, I have to go back and add a bit more scan spray. So in this case, I got as much as I needed for the first scan. We're going to flip it over, add a little bit more scan spray in some areas like the center that were not coming through on that first scan. And as long as we capture that area with a second scan, it doesn't really matter. We can go over and extend past that area. Now, in terms of settings, for the most part, you just need to make sure that the exposure value is okay. When I'm using scan spray, oftentimes I use manual exposure, and I'm actually setting it relatively low here. So it's still set at 1. Generally, you want to increase the exposure until you get to the point where you're getting a little bit of red highlight. If you want to use auto exposure, that's perfectly fine. I tend to use auto exposure when I've got multiple different surface finishes or materials or things like that in a single scan. Auto exposure kind of helps with that. Manual exposure, you can still bump up or down during the scan process. In this case, I left it at 1, which was a bit on the low side, but you can still see in the preview in some cases we do get red depending on how close or how far we are from the object. One thing that is important to know, whether you're using a Metro X or a Morocco or any other scanner from any manufacturer, is to capture more data than you think. Now, if you have a problem, like in this case, there is a shiny spot in the upper sort of quadrant of the headlight, this is telling me I didn't have enough scan spray. I'm never going to pick that up clean. I try a couple times, use the undo function to make sure that I didn't grab, some bad scan data because it's going to be a little bit harder to clean up later. Then go back and add more scan spray if needed. Generally, you don't need too much scan spray for most objects, but when we're talking about something that is clear, then it really needs to be completely coated or covered. The chrome on the back, again, is another thing with it being so shiny that really needs to be completed and covered, and then a little bit of breathing on it or just blowing on it to speed up the process of it off-gassing. That will help us out so that we're not wasting too much time. Now, of course, I'm narrating this after the fact, but everything here is real time. So this is this is how much time the process is going to take. It's really not that long or that difficult with a part this size, but the trickiest part is certainly just the surface finishes. Now, this is 2 scans in. I'm going to continue on scanning the backside. And for this, I like to set the part up above the table just a little bit, mainly because as I wrap around the side, I want to get a little bit of the front lens if I can. And I don't want to have to trim off the table if I end up using that portion of the scan. The backside's a little trickier than I thought it was going to be. You'll notice on the right-hand side that my distance is okay, but the lack of features on the back, I didn't think would be a problem, but you can see that there's some tracking issues where it starts to spin around. This typically happens with circular features. So because the back portion of the headlight is circular in nature, it tends to have a little bit trickier time. So the best approach here is to really make sure that your first frame or your first couple frames include a corner or an edge or something that has enough of a unique identifier that the mesh itself isn't going to start to spin. So the side of the lens is kind of rounded, but the top section here has got a corner on the right side and a corner on the left. This is a much better scenario for us to make sure that we don't drop tracking. Now, once you get this section and start to move around, it's not as big of a deal because then it has more information, more references that it knows where that geometry, those points are in space. It's really just the first couple frames when you're starting out that you need to make sure that you have something like a sharp corner or a plane with a feature on it, something that can't easily be misconstrued as another portion of the design. So here I've got the top portion working my way down to that slotted mounting tab on the bottom. Just going to work my way forward and get as much as I can from this side, because again, we're going to use 4 scans merged together. So the approach that I generally take if I can't get something in one single scan would be to break it up into quadrants. And then if we can just break it up from like a symmetric standpoint, left and right, that's perfect. But breaking it up into quadrants and then at least have 10 to 15% overlap between those. What you'll find is the edge of the scan is typically going to be the noisiest. There's going to be more deviations in those points. We're going to end up cutting them away. So you want to make sure that if you have a scan of, let's say, the left side of the light, you go 10 to 15% over the center line. You scan the right, you go 10 to 15% over the center line as well. And then we can hack a clean, sort of a clean section in the middle. So that way, when we merge them, we don't have a bunch of noisy points in those areas. Is it really required? It kind of just depends on what you need to do with the scan. In this case, I wanted a good quality scan of the headlight so that I could have the references on the back, I could have the references on the front for the shape, even though I'm not going to use things like mesh section sketches or freeform modeling connected to the scan. I wanted it to be as good as possible. So here we're going to do the 4th scan. In this case, what I'm trying to do is get a good section of the bottom of the headlight and roll underneath. So again, it's important that when we're merging these together with multiple scans, that we do have enough of that overlap. So you can see here that scanning the bottom where that slotted mounting tab is and rolling underneath so that we can get the portion of the backside of the lens where the reflection is going to happen with the light bulb, get the backside of that. This means that the upper edge where it connects to the front of the lens can be trimmed away. If you happen to see a preview on the screen jumping around and you think you've got some bad frames, it's much easier to pause the scan and hit the back or undo button now, because if you have to modify that later on, then you're going to have to go through all of the frames to find out where that was. You can see here, because I've got the reference underneath, I was able to go completely over the lens and get a good majority of the headlight. But you can see here, if I try to restart on the lens where there's really not very many features, it just wasn't able to know where those points were. So hitting undo a couple of times just to clear out those frames that we don't want, that'll leave me with a nice clean reference. So I'm going to try one more time, start the scan, see if I can get it to find that bottom. Once that red turns green, then it was able to align it, and now we can move our way around. What I found with RevoScan is within, maybe 2 to 3 frames, if it notices the new frames are off, it will actually jump and fix itself. But if you go further than 2 or 3 frames and the scan is off, you certainly want to hit that undo and back button. I think this looks pretty good. Obviously, there's a little noise on the edges, but overall, I think that the scan looks pretty good. We can go back and try to capture some of the areas that are missing. Once again, it's going to be a bit of an exposure challenge and a little bit of scan spray missing on the lens in certain areas from flipping it over. At any point in time, if you need to, just add a little bit more spray. Once again, you can just blow or breathe on it to speed that process up. That way we don't have to sit around and wait for a minute or two before we actually can start scanning again. So now you can see the scan is now clean in that corner, so we don't have a little hole there. This is going to be probably one of the better scans because it has so much detail on the front and the back. Whether or not we even use that scan, it'll still help with the manual alignment. And like always, everything's set up, scan sprays on the part, capture a couple of extra frames, capture more data than you think you need, just in case you find out later on when you're processing this that you're missing something. Now for me, I generally capture with the laptop in the garage and then I process on my desktop. I generally don't like to process it on the laptop, not for a performance reason, just because I prefer having a full keyboard and a mouse and just my normal setup. It can certainly be done here in the garage on the laptop, and I've done that before, but it's just much easier for me to just do it at the desktop and just sync all my files in one place. So again, this is kind of just extra. I don't really need this scan, but going through the process of just capturing a little bit of extra will make sure that we have enough when we go to process. You can see there's one spot where it's struggling. Again, it's an area where it's still a little bit shiny on that lens. It's having trouble with tracking, so hit undo a couple of times. Make sure that we go back to before we had any issues. Should be pretty noticeable on this part. You can see right there, that looks pretty good. So I'm gonna call it here on the scans. I think that's everything we need. And now that we have all of that scan data, we want to make sure that we also have scan data from the bike. So I did use the Morocco for both the headlight and the bike, but I ended up not using the Morocco headlight scan just because the Metro X one was better. But in this case, because we have so many different materials, we've got the chrome on the forks, plus the aluminum for the levers and the bars, and the triple clamps anodized black. We've got cables, all kinds of things. Just going to do a light dusting of the 2 to 4 hour scan spray from RevoPoint. This is going to allow me to pick up detail on the tank, which is the main thing that I want here is the lines of the tank. And then I can get a little bit of extra information from the forks, where the wheel is, front and rear wheel, some on the engine, just kind of an overall picture of the bike. While it's not really necessary, it is helpful from a design perspective to be able to get just a little bit more extra information into the computer, so that way we can follow the lines of the tank, follow the lines of the front fender that we designed. We can line it up with the triple clamp and so on. This process with the scanning of the bike doesn't take that long if you're not trying to get a full detailed complete scan. If we're just looking to get these quick references, then probably spending a couple minutes putting some scan spray on, probably spending 3 to 5 minutes to capture a scan, and then probably another 5 to 10 minutes to process the scan is all it's going to require. If you want to go and do a full scan of a bike, that's something that's going to take quite a bit more time. So in reality, what would happen is you would need to do more prep depending on the scanner you're using, and you would likely spend probably close to an hour or more if you were trying to scan the entire thing and get good detail. It could obviously take quite a bit longer. If you've got a bike that has bodywork on it, that makes it much easier. This bike doesn't, obviously, so getting all the details of things like the carbs and the engine and all sorts of stuff there, that makes it quite a bit trickier. So The Morocco, in this case, it's the Morocco Plus, but for what we're doing here, any of them would be fine. Basically, the idea is to get a frame of the front end first, so it's got the references of the forks and the triple clamp, and then work my way around to get the front end and work onto the tank. So you can see here, pretty easy, just one-handed, being able to capture the right side of the tank. Again, not really needed for what we're doing here. All I really need is the left side view and some information from the front, but while we're here, while I've got spray on it, might as well try. Now, because there's so much going on with a scan like this, if you lose tracking, just go back to a known place that has good detail. In this case, the front master cylinder and the forks had enough detail that the Morocco was able to find that tracking again. We are using far mode here, obviously, because we're pretty far away, trying to get basically a large object, not a lot of fine detail. If I was trying to capture detail about the triple clamp and mounting points on the frame or anything like that, I would want to use near mode for those. And you can switch between far and near mode on the fly with the scanner. In this case, I'm not, obviously, but you can do that. Just going to speed it up because it's pretty much all the same, just going back and forth. This is just capturing a little bit more detail, a little bit on the front end, and capturing the wheels. I'm going to get the tail section a bit from the left side. That way I've got that reference in there, and capture the swing arm and the rear wheel. Again, just for sort of visual references so we can see where they are in 3D, not something that I'm going to try to mesh and use. The next step of this process is to go into RevoScan on my desktop and begin to process the scans. For the actual bike scan, very minimal processing. I don't want to remove all the noise. Using things like isolation and overlap detection would probably remove most of that. But for the headlight, we do need to go through each step in each scan that we're going to use and clean it up. So the first step of the process, if you're doing it manually, is to go through and use the fusion process. Picking the size or the resolution between those points is going to be based a little bit on the scan mode that you're using and what you need out of that scan. So I used a point distance of 0.44. With scanning with the sort of full field mode, I could have certainly put those closer, but I didn't need any higher level of detail than that. One thing that is really important is on the fringe of your scans on these edges, you want to make sure that you do delete and clear out anywhere that there's a lot of noise. Now, again, this happens on the edge of the scan. If the scanner is at an extreme angle, this will happen, but also just when you get to the edge of where you've scanned, it's typically going to be noisier if you didn't go all the way around the part. So it's good to make sure, again, that you scan past 10 or 15%, but that you come back and you clean this up. And the main reason is because when we go to merge multiple scans together, when they overlap and all those points get fused and merged together, then we're going to have a bunch of noisy points in those areas. So do what you can to clean this up, as long as you don't need those areas for merging things together. Same process with the other scans, again, starting with the fusion process, which I'm using 0.44 for the point distances. This is all real time. I'm not cutting anything out here, so this is how long it takes, and there's no tricks to it. Unfortunately, you got to sit through the process here, but for the most part, you should expect this whole process to take about an hour to an hour and a half, from prepping the part to putting the spray on it, to scanning, to processing the scans, and manipulating the mesh however you need, and then doing your design process. So just keep that in mind. I could do the entire process in probably about 30 minutes from the initial scan to the design, but that's kind of speeding through it, right? And having done it before and knowing what to look out for. So once again, using the default settings, find those extra floating points with isolation, find the overlap detection, which is going to be extra points. Generally, that happens based on your exposure value settings and the shininess of the material. Shinier materials will end up having more points floating in space above the scanned part. So in this case, again, cutting away anything that is sort of jagged So you can see there right on the edge, all that stuff is very noisy, and that is going to have an impact or a problem when we go to use this data later. So just do your best to clean it up. I know a lot of times it can be difficult to hack away stuff that we've scanned because we think, oh, we might need that, but it's going to be much better for the final result if you can delete and get rid of that. So in this case, just cleaning up everything that we can and moving on to the next scan. Once again, Fusion 0.44, pretty much all the same settings. Again, I've mentioned it before in a couple of videos, but if you go through this process and your scans look very bumpy, like you painted them, they've got a lot of orange peel on it, generally that problem's going to start with the quality of the scan data. If you happen to have your exposure value set too high, you'll notice problems with that. Or if you've had it too low, you can also have some problems with that. But the other thing is that when you go through the fusion process, oftentimes your point settings could be just way off. So it's a good idea to play around with your parts and go ahead and try to set that setting higher, like 1 millimeter, and then set it lower and see what the results look like. If that sort of doesn't make a big difference, if you notice that 0.44 and 1.0 look about the same, then the next step in that process is to go through and use some of the smoothing techniques at the point level. But remember that you want to limit the strength value of the point smoothing, and you really want to focus more on the number of times if you're trying to get a highly detailed model, because increasing the strength, what this means is it's going to allow the points to float and move more on your scan. And the number of times with a low strength value, we'll go through multiple times, moving those points just a little bit each time. That tends to keep the quality or the accuracy of the scan a little bit better in most cases. Now, there are certainly some cases where it doesn't matter, but in most cases, if you have something detailed, then you want to do that. All right, so again, Fusion on this scan, gonna clean up what we can. Again, removing the little cap I had it sitting on and the workbench. Then use isolation detection. Most of the time I use that standard 15%. It gets most things. For stuff like the bike scan, which there was a ton of noise in, I actually used isolation detection, but I set the percentage down at like 4 or 5% because there was so much noise that I wanted to keep little bits and pieces of things like the brake rotor and the rim, parts of the engine, parts of the oil cooler. And the isolation detection will get rid of a ton of that stuff. So you do need to play around with it. These last two scans, or really the first two scans, I'm not going to use. Again, it's important to take more scans than you need. Now with merging these together, the process of using the feature alignment has always done pretty well for me. And generally what I do is align two scans that have a good amount of overlap. Then I'll add a third one in, make sure that everything looks like it's in the right spot, and then add a fourth one in this case. That will give us everything we need for this part. There are still a couple of holes in the scan. Not too worried about it. As long as everything that we need is covered, I'm not so worried about any areas that just have little holes in them. But for the most part, you can see everything looks good. It allows us to generate the model, which is essentially going to take all these points and merge them together in one point cloud. This is why it's important that at those fringes or edges of those sketches that we did clean them up before we merged them. Anything that we didn't clean up is going to produce a problem here. What I like to do after merging is go through isolation and overlap detection just to make sure there aren't any points, extra pieces there, and just take a look at the final results. So there are areas where it could be better, but for the most part, now we can convert it to a mesh. And the mesh setting here, the quality, is going to be defined, or it's going to define the grid, the triangle size of the final mesh. Part of this number is going to come from the point fusion number that we use, that 0.44. And generally what I do is I make the mesh quality setting larger. So in this case, make sure that the metric number is larger than it was at the point level. If you try to make it smaller, things get a little crazy. If you make it exactly the same size, it could work fine. But just making sure that it's a little bit bigger, but still small enough to capture the details you need. We can still see there's a little bit of noise on the front. There is a hole here. What I want to do is just fill that hole in using the curved method. Allow it to select it, should turn red. If you accidentally select other holes, you'll have to use undo. So in this case, the hole on the front is fine, but on the back, I accidentally selected trying to fill in that big hole on the back. So obviously that's a problem. So just make sure that if you have that problem, just use undo. It's pretty easy. Just click undo and redo the filling of the hole. Once that's patched, then in this case, I'm going to go through and smooth it. Once again, turning the strength way down, increasing the times is going to have the final mesh model be much closer to the original. You can do this multiple times, but double check areas where you have sharp corners or details that you want to keep, because this process can very easily round and soften sharp corners. And if you need to capture those for things like a mesh section sketch, then it's going to cause a problem. Now, when I go to the simplification process, I generally go to my display settings and turn on the edges over top of the mesh. The simplification is going to take our design here, and it's going to try to simplify it based on a percentage we give it. So for example, 40%, it's going to take, let's say we had 100,000 triangles, it's going to try to take it down to 40,000 triangles. You can do this process multiple times as well. You can adjust the ratio and regenerate it. One thing that's good about this simplification process is it does actually look at the angle between the triangles. So areas where there is a curve, it'll keep a higher density, or like a corner or a fillet or something. And areas that are bigger and broader, it'll generally replace those with larger triangles. You can go through this process multiple times. Just double check to make sure that you aren't decimating your design. Make sure that the corners are staying nice and crisp and you're not losing any of that detail. So turning the mesh display back off, we can see that on the back side it still looks pretty good. Now, in reality, if I needed to do a reverse engineering job on this, I would have spent more time scanning it, especially the backside. But for what we're doing, I really just need those points in space, and I need to make sure I understand the overall shape. For this process, I am going to use Quick Surface Light. This is going to allow me to generate some primitives, some planes, and different geometry that I can use to align this. The bike alignment is not critical because it's just a visual reference, but getting the headlight aligned to some coordinate system is going to be key. Now, with this process, I've tried a few different things. I tried to create a cylinder based off the location of the headlight. I wasn't super happy with it because I didn't remove the rubber boot that went on the back of the headlight, so I didn't get a clean or crisp edge. And that wasn't really aligned very well. So what I ended up doing is using the bottom mounting, which I thought was centered, but it's a little bit off. But using that bottom mounting tab to create some planes, and then I can use those planes to create a mid plane. So that theoretically should be at the center of the design. And then I can use the mid plane, and I tried to use the cylinder in the center. But in this case, it was just a little bit off and a little bit twisted. So we can see it's not quite aligned. If this is something that happens to you, then it's always a good idea to just take a step back and think about the process of aligning this part in a coordinate system and what would be that first or that primary reference. In this case, the primary reference of the midplane would be fine because I don't really care that XYZ would be centered at the headlight bulb, for example. All I really care for this design is that it's centered left and right, because that's going to mean that when we use freeform modeling and symmetry, then that we're able to sort of work with it in that respect. So looking back at this design, what I ended up doing was using some of the features on the backside and just going from left to right and creating a line between them. Now, this is an average of the selected triangles, but that line, that reference, is going to help me get the headlight oriented along X, Y, or Z, depending on what I need. And then the midplane that I used is going to be my primary reference. And then that line is going to be my secondary reference. And then I want to make sure that I apply this to all the features, which means that the planes that I created, any cylinders, all of those things are going to move. Now, if you're using Quick Surface Light for your designs, then you can export those primitive features, the planes, the cylinders, and things like that. So if you're using that for reverse engineering, you could certainly do that. In this case, all I really need is the mesh, and I need it aligned in Fusion. So what I'm going to do is export the mesh once I'm happy with its alignment. So this looks pretty good. I know that on the KTM, that the headlight is a little bit different angle, but this is going to work for me. So selecting the mesh, going to export the mesh, and then bringing that into Fusion and making sure the coordinate system is right. And everything here looks pretty good. It's not perfectly centered. I think I mentioned, or I will mention during the design, that tab on the bottom is actually slightly offset. So the mid plane didn't give me a perfect center line, but it's close enough for what we need to do, because we are going to have a slight gap around the headlight once we cut it with the form tool, or once we cut it with a sketch after we use the form tool. For the bike scan, again, the bike scan, we're not going to go through the process of doing anything with it in RevoScan or aligning it really in Quick Surface. That process was a bit more of a pain because I didn't capture enough detail that I really had good features to work off of. And because I used far mode, I had a pretty low resolution scan because I was doing it quickly. But we can see here that the bike reference, at least graphically, is going to be fine. We just need to get it oriented roughly okay in XYZ. So in this case, I need to rotate it 90 degrees. If you need to, you can always expand numerical inputs, and that'll make sure that you are using 90 degrees. We can snap it back to the origin. So if you need to show the origin just to make sure you know where it is, you can select the position option to center it, or move it to ground depending on where your scan reference is. And then just double check where the orientation is relative to the headlight, and then manually move it into position. Once again, this is a rough approximation. It's not really that critical because of the way that this headlight mounts, using rubber straps to the fork and an extra tab that I'm going to design after the fact to the bottom triple clamp. So really, it's just making sure that we've got a good visual reference, making sure that it's, approximately centered. Generally, it would be a good idea to have a better scan and make sure that the scan is properly centered in something like Quick Surface. But if we need to manually tweak it here in Fusion, it's not really that big of a deal for what we're doing. So I'm pretty happy with the alignment. The headlight is the critical bit, but I have all of the details of the flow and the lines of the tank. I know where the forks are. I know what the tail section looks like. That is everything that we need, at least for our design reference for this. Keep in mind that you also want to make sure you right click on these meshes and make them unselectable. This is because in Fusion, when you hover over a design, it's going to try to highlight the faces and the edges. And when you have a mesh, you've got thousands of triangles, thousands of edges. And anytime you move the cursor over that, it's going to highlight and it's going to bog the computer down. All right, so now if you want to follow along, if you go to the description of the video, you can find a download link that has the headlight scan, the bike scan, as well as the final or near final shape of form. And what we're going to do is we're going to use this, but create our own. So that way we've got a reference for the one I created if you want to look at it, but we can also explore how to do this on our own. Now, at this point, the scan of the motorcycle is messy. And it's known messy because I didn't spend a lot of time on capturing all the data, right? I mean, you can see there's a little bit of the cylinder and the carbs, oil cooler here in the frame. But the main thing I needed was a good side view of the tail section, the tank, and then I also needed to know where the forks were, where the clip-ons were, where the triple clamp was. So this was just kind of a quick scan to get the data I needed, whereas the headlight was a more detailed scan to get all the data that was important. So this is one thing that we need to keep in mind. We could spend loads of time getting good, clean scan data of the entire bike, but the downside to that is it's going to be a lot of triangles and it's going to slow things down. So with this scan, I know where the wheels are. I know where the ground is. I know roughly the attitude of the bike. I know it's on a rear stand right now, but roughly I know how it should sit when it's level on the ground. This gives me everything that I need. In the bodies folder, we want to make sure that both the headlight as well as the scan are both not selectable. So right click on them, make sure that they are not selectable. This will greatly increase the performance because when we roll the cursor over it, it's not trying to highlight every triangle, every edge, every face. And that's one of the big things that slows us down when we're dealing with these mesh files. Trying to do a remesh on something like the body with all these disjointed pieces would not go well. So I suggest if you don't want to see it, just hide it, and that'll speed things up as well. So the next thing that we are going to do is we want to make sure that we're on perspective with ortho faces. Also, when you're looking at a design, you always kind of want to see it with perspective. But when you're designing, you want to be able to be in an orthographic view that's going to help with understanding where edges are in space so that things on the opposite side of a design, a symmetric design, are going to be in the right place. The last thing that we want to talk about here is that when we go back in and create a new form, we want to make sure that any solid bodies or surfaces that we don't want to see are hidden. And the main reason for this is because if this is visible, it's going to become a ghosted image when we're in the Forms workspace. We can snap to it with certain tools, like the associative match tool will let us snap to an edge. But for our purposes, we don't want that. So I'm going to go ahead and turn that off. We can always finish the form and come back. Then we're going to start a new form. Now, there are a couple of ways that you can approach starting a new form. For me, I'm going to hide the bike. So in the bodies folder, hide the bike because all we really need to see at this point is the headlight. And we need to look at this headlight design. We can see the darker edge here. This is really where the shape of the headlight is going to come from. Then we're going to sort of work our way back. So when I look at a design like this, when I want to start a new design, I would often go to using extrude from a sketch. And the reason for that is because when we use things like a plane or a face, those are going to be much more difficult for us to get the right shape to start with. So create a sketch. We're going to select the back or the front plane, depending on which way you're looking at it. I'm going to zoom in a bit so we can see these edges a bit better. And if we take a spline, what this is going to end up doing is creating a curvature-based extrusion. We could just do a simple straight line. So for example, we could go from here to here and get it as close as possible. A right click and say, okay. And then we can finish our sketch, go to create and extrude. Select a sketch. We're going to rotate this around. And as we begin to pull this out, we can change this to be uniform distribution and start reducing the number of edges. We don't need that many at this stage. So 3 is probably going to be okay. And then we also want to make sure that we have symmetry. Now, when we look at this, the way that we get symmetry when we're using extrude is to say symmetric and then keep embedded symmetry. When we keep embedded symmetry, if it goes crazy like this, and this happens from time to time, and I don't really know why, but if it happens like this, then all we need to do is turn that back off. We'll say okay, and then we'll instantly go to our symmetry tool and then allow it to create the proper symmetry. So again, if that happens to you, just turn embedded symmetry off and go and add it manually. If it doesn't happen to you, then congratulations, it worked for some reason. Now I've done this shape a couple times, and that was the first time it went kind of crazy on me. So just keep that in mind. Now we've got the start. All right, so we need to look at this. Currently, it's going to be in smooth display, which you can't really tell because it's flat. But what we want to look at is where the plane or where our freeform model is going through our headlight. So you can see that we've got a bit of distance here, but it looks pretty good everywhere else. So what this tells me is that I need to start adjusting this shape and getting it closer. And what this means is that this point in the middle is likely going to move out. And I'm going to go back to the side view here. I'm going to go to modify, edit form, and I'm going to begin pulling this forward. Now, as I pull this forward, it's going to leave these edges where they are, but it's going to start changing the shape here. I'm going to rotate this around, grab this lower point here, and I'm going to start pulling this one forward as well. So what we want to see, or what we want to work toward, is getting our shape, our freeform shape, to cut through the headlight where we want it. And this is going to take some slight adjustments. So grab this back edge by double clicking and maybe pull it back a little bit. Come up here, maybe take this point forward a little bit. And then maybe take this point back a little bit. And just do some minor tweaks at this point. Now, the reason I say minor tweaks is because we're looking at this in smooth display. And when we start this process in smooth display, you'll notice that the shape is kind of got this curve to it where it bumps up and bumps back down. If we change our selection filter to be our point option, what you'll notice is that all of the edge points, the tangency direction is still going sideways. And this is a potential problem that you'll run into until we start to add more edges. So what you can do is you can reset these. If you click on them and click this, so kind of roll back and select each of these and click that little chain link there, rotate around. There's going to be one in here, this one here. And because we're dealing with symmetry, it should take care of it on both sides. But what you'll find is sometimes when you start a new design like this, that those handles end up maintaining their original tangency. So you gotta be careful with this at the start of a design when you still only have like 4 faces to work with, because once you get further in the design, that becomes a much bigger challenge to deal with and having to sort of address that. So what we're going to do now is continue to make some minor adjustments, kind of pull these edges back. I'm going to take this edge back a little bit, and maybe this bottom one here, the bottom point, pull this back, and then maybe pull this one forward. At some point, you're going to find that you don't have enough divisions to match the shape, but we're just trying to get it close at this point. So far, that looks pretty good. Next, I'm going to go to a front view. We're going to change over to box display. And box display is really important because we don't get too hung up on worrying about or dealing with the final smooth display shape. So under utilities, we've got the display mode, which will get us to box display. We can also go into our selection options while we're in edit form and select box display, or you can use the shortcut keys Alt and 1 or Alt and 3 to go back and forth between box and smooth. Now, you'll look at this and you'll say, okay, well, we just undid everything that we started with. Well, that's not exactly true, because box display, I'm using Alt and 2 right now, box display is going to be the main driver of our curvature, and it'll translate into the smooth underlying display. So if you want to, you can use Alt and 2, which will give you this sort of control cage display option. I like to just go to box. I know that we're close with the shape, so I leave it in box display. The next thing that I want to do is I want to begin adjusting the outside shape. So at this point, I want the outside shape to match, as best I can at this point, is to match the underlying shape. Now you may need to go to, let's say, a back view or a front view, but basically what I'm doing is I'm going to pull these in and I'm going to start to get this to the headlight shape. We will have to go back and forth making some adjustments to what we did already in smooth display, but basically this is going to be our rough shape or our rough outline. Pull this one down a little bit. Okay, so now we're there. We're going to go back to smooth display, again, Alt and 3, and see how close we are and how much we've messed up. So it's not too bad. It's inside a little bit, but that's to be expected, but it's not too bad. So now that we've got this rough shape, we've got 2 directions or 2 things that we want to think about. One is, are we going to continue to build vertically and then out horizontally? Or the other direction would be to build out horizontally and then build up vertically. Now, the reason you would decide one of those over the other is based on the flow of edges and creases that you want to use. So for me, it's going to be a bit more beneficial that I work out, because that's going to be the driving shape here. And then I'm going to roll the bottom and roll the top up to get those shapes to work how I want. So I'm going to double click this side, go to my view that's looking at the front of it, hold down the Alt key, and I'm going to pull this out. I'm going to let go of Alt, rotate around, go to the side view, and I'm going to pull this backwards. Now I'm going to do this one more time. From this view, I'm going to hold down Alt, pull this back, let go, And I'm going to rotate around and just kind of take a look. So again, this is a rough shape. We're going to have to do some adjustments and some tweakings, but this is where we are. The next thing that we need to consider is how much influence the extra edges are having on our design. And what I mean by that is if I go back to this Alt and 2 display, basically our box display is way out here in space, but our smooth display is way back here. Now, this is the trap that most people fall into. They start moving around the smooth display a lot and they get lost in the design. Now, if I go to a box display, Alt and 1, the box display is still pretty close to that original shape that we're working with. And again, smooth display is pretty far behind. Now, what ends up happening is when we start adding more edges, people really want this edge, for example, to be a much tighter transition than this edge. So if we double click on this and we use modify bevel edge, I'm going to increase the crown. We're going to use this 0.2 offset ratio, increase the crown all the way up to 1. And what this does is it puts the new edges 20% of the distance between our selected edge and the next one. And the crown, if we rotate this around a little bit, this peak right here, this transition, is going to get adjusted. If we leave it at 0, it'll be completely flat. If we increase it, what this is going to do is essentially pinch the corner a bit more. So when we say OK, now that brings those edges back out closer to where we had them originally. Now, if we repeat this process with this edge, right click, repeat bevel, again, we'll increase the crown, making it a bit tighter. So now what we're doing is we're building out these edges and it's pushing those transitions out further. So this is why I say people can very easily get lost in these designs, because once we really focus on smooth display, we get into trouble because we start moving things around drastically to make them fit, when in reality, all we need to do is some minor tweaks, tighten up some corners or transitions. It is always good to go back and forth between smooth display and box display though. For example, as I'm looking at this entire green edge, I want to pull in a little bit. I'm going to go back to smooth display and then take a look at my results. Now, as I'm looking at this, I'm thinking that I need an extra edge up here going across, and maybe an extra one down here to help control the shape. So I'm going to go to modify, insert edge, double click. I'm going to use exact, which will keep the exact same shape that we have now. Say OK. Right click and repeat that at the bottom. Double click. Again, exact keeps the exact same shape we have. And now I can take this entire edge with edit form, and I can begin pulling it forward and up as needed. And then we can come up here, start to pull, undo that, double click, and then start to pull this whole edge forward. And you can see we're matching this transition. But again, we want to be very mindful of the fact that at this point, we've added the bevels so that we're keeping the shape closer to our original intention. Now, if we were trying to do this with much fewer faces, then really what we're doing is we're making drastic changes to the overall shape. So that's looking pretty good so far. I think from the side, I might want to bring this up a little bit. And I think that's looking pretty good. So the next thing I want to do is I need to finish off going vertically at the top, and I need to wrap the bottom under. But when we start to wrap the bottom under, we want to begin to think about, well, how wide is this? Do we need to move edges in? And again, this is where we want to go back to box display. So with box display, I can double click all these edges, holding down shift, make sure that I get all of these edges here, and then simply pull them in. Alt and 3, go to my smooth display. That's looking a bit better. If we want a tighter transition, we can use tools like bevel again, or we can slide edges or insert new edges. I'm a big fan of the bevel tool. So what I'm going to do is bevel. I'm going to go ahead and increase this to 0.5. Tighten up that transition a bit. And again, just kind of working with those general shapes. Now, as I mentioned before, the version that we make here is not going to be exactly the same as the one that I've already produced, just because this, again, deals with a bit more artistic influence. So you're going to have to play around with these shapes, and you're going to have to figure out what works for your design. Now, as I'm looking at this, I can already tell that I don't like the fact that the outside shape doesn't match my headlight shape. If I go back to my box display, I think that what I need is another edge in here somewhere. So I'm going to double click this. I'm going to say insert edge. I want to go the other direction. Let's go down about minus 0.5. Now, minus 0.47 probably won't work, but because we're using exact, it's actually going to move it for us. And then I'm going to double click this and scale it inward. Then we'll double click this one, scale it inward, and go back to our smooth display. And maybe this one, double click and scale it inward, double click and scale this inward. Scaling is a good solution to a lot of problems, but it's not the solution to every problem. And the reason I say that is because when we're scaling things horizontally, it's also going to start to tighten up some of these transitions, and sometimes they'll get looser. So it's not a solution for every situation, but it does work in a lot of cases. I'm going to insert some more edges. This time I'm going to do both exact and say OK. And once again, I want to really control this transition. So I'm going to go to Modify and Slide Edge. I'm going to pull this down a bit closer to where that edge is transitioning. And then maybe slide this one down as well. All right, so that looks a bit better. It's a bit tighter of a transition here, and then it's a little bit straighter. What this tells me is I might even be able to get rid of this edge altogether. So double click and hit delete, and that's looking a bit better. And then maybe scale this one in just a little bit. And then I'm going to take this one, double click, shift double click. You want to definitely make sure it gets the entire edge and maybe scale them out just a little bit. And this one as well. Whenever you're working in forms, using things like scale, whether it's scale to a point or you're scaling an entire curve, those are good gradual ways to make changes to shapes and designs. We will need to do a bit more work. So that extra edge I deleted, that was really there because of this extra geometry. So now that we've sort of smoothed and cleaned things out, I can go ahead and just add it back in manually. And then edit form and pull it forward and up a little bit. Also going to go ahead and take this one forward and up a little bit. You can see here we're now starting to overlap. You can make individual changes at points. I would avoid it until you have more experience because you can get your designs out of shape pretty quickly. All right, so now the rough shape is there. Just need to roll the bottom around and kind of finish off the top. So I'm going to double click on the bottom. We're going to hold down Alt and begin pulling this down and back. And then I want to rotate. So we're going to rotate this. Going to rotate around to the side. It looks pretty good. And then probably need to do it one more time. Alt, pull it back a little bit and rotate. And then I want to scale vertically and tighten it up a little bit. So that looks pretty good. If we want to flare it out, again, using tools like scale, we can add a bit more shape to it. You can pull it in, you can pull it out, and just play with it and see what looks okay. Now at the top, something very similar. I'm going to go ahead and pull this down, hold Alt, and just rotate it slightly. And I'm going to scale down to a point. Just kind of pull that in until it looks okay. Now from that view, it's different than the original one, but that's okay because, again, the whole point of this is for us to play around with these tools. But once again, it's freeform modeling, it's direct modeling, so you can move things around at will and make changes. Go ahead and pull that up. And then let's go ahead and pull this up. This tight transition here might present a problem, but for right now, I think it's okay. I am going to go to modify and bevel. I'm going to take this edge here. I'm going to increase my offset ratio, which is, again, that's the basically a percentage from our selected edge to the next one. So now the edges are going to be added at 30%. Going to increase the crown and say OK. When you get geometry that's pinching in a corner like this, it's always a good idea to go back to your box display. More times than not, you'll have an overlap. So if I rotate this around, you can see that it's sort of overlapping on itself. So what we want to do to manually fix this is select that point that's way down there and manually bring it back up. So anytime we have a transition like this, you want the transitions to be gradual. You don't want this to go down to a triangle. You want it to be fairly consistent. And if we go back to smooth display, that will have helped that crease out. And a last step to that, you may need to go to utilities and go to make uniform. And what this is going to do is it's going to take all of the faces on here and it's going to try to spread them out. So what that means is it's going from our smooth display here and it's trying to make it more akin to our box display, kind of stretching this out. I also don't like this transition right here. That edge doesn't look very good, so I'm going to pull it back and down a little bit and rotate it. And there we go. So once again, play around with this, make your final design changes. So again, if you need to tweak a couple areas, you can play around with it. If you're moving things very gradually, smooth display is okay. If you're making more drastic changes, I do suggest going to box display and making sure that you look at the transition angles between each edge and each face. So looking at the flow of these edges in box display is going to be a much better indicator of how well this is going to work. Now that we've gotten a shape that looks pretty good, the next step in this process for me generally is to copy this. I'm going to just do Control C and Control V. And the reason for that is because, again, Forms is direct modeling, which means that we don't have a timeline to go back and like unthicken a form. So if we want to create a thickened form, then I'm going to do -3 millimeters. So it's going to be inward. Let's double check that. Yeah, so we want to go -3 and say OK. And then areas where we might potentially have a problem would be those tight transitions. Everything looks okay here. But now we've got our surface version and we've got our solid version. And that performs two operations for us. One, if we don't like this, we can always delete this, go back to the surface version, make a copy and make more changes. But also when we click Finish Form, this is going to give us our surface, which we can now use as a stop surface, or we can do some trimming, or we can do whatever we need to and thicken it here, or we can continue working with our solid body version of this. So that looks pretty good. We do also want to bring back the bike, at least the scan, just kind of see where this hits that lower triple clamp, make sure that everything looks okay. Because of the way that we did the triple clamp in the last video, I could bump up the center section of this mask. I don't really feel the need to do it on this version, but again, that's just a design thing that we could play around with. But what we want to do at this point now is add in the rest of our features. So the first thing for me is to cut the opening for the headlight. So I'm going to do this on a front sketch. So just kind of look at it from the front, and I'm going to use my line tool, and I'm going to start, let's see, at the origin and come up. This is just going to be a reference line. So make it construction. And most of this is going to be straight lines. So what I mean by that is if I go from here out to this corner, that's fairly straight. This one is going to be some sort of arc, but this one down here is fairly straight. And then back down here is fairly straight. You can see that the headlight's a little bit off center. Again, I mentioned that in a previous video or previous section that the little tab that I use to center the headlight is actually slightly off center, the adjustment tab. That's okay because we're going to leave enough gap to make this work. But now what we want to do is play around with these edges until we're happy with their location. And again, this one is going to be an arc. I'm just going to go ahead and do a 3-point arc from here to here. Could be a spline as well. And then get rid of this line and just kind of pull it until it looks right. Again, and I want a little bit of gap. So I don't want it to be a perfect fit. And once we're happy with that shape, I'm going to come back with some fillets. So looks pretty good. Looks pretty good there. Maybe increase it a bit. No. I actually hit escape, and I want to add a different radius value to this one. That looks okay. 20. Right click to OK. And we'll do this one down here. 10 looks okay there. The bottom one's not going to work because we're going to have to mirror this, but we can round those off once we actually cut the geometry out. I'm going to pull this up slightly. There we go. So double click it, select mirror. Our mirror line is that construction line, and we'll say OK. So now hide the headlight, bring back the solid body, and just do an extrude. Now, if you notice it's not selecting the profile, that probably means that the mirror didn't connect at the bottom. And what that's telling me is that I need to go back into my sketch and just make sure that I've got a closed profile. And again, generally this is a problem at the bottom. So I'm just going to select both of these and make them coincident. And that works because we're dealing with a mirror. So it's going to pull both of them to that center line. Now we can bring the headlight back. We'll have a profile to select, and we can pull this out in both directions. I'm just going to say symmetric for this. It'll go all the way through and say OK. So now we're going to use a fillet. So F on the keyboard or select it here. And we'll round this off. If you need to bring the headlight back just to make sure it's roughly the right size, go ahead and do that. And we'll come up here, hold down Control, select that one as well. That one's not going to be as big of a deal. All right, so it looks pretty good. We've got a gap there. The headlight should go in from the back just fine. And everything looks lined up. Another fillet that I do want to add is I want to round these corners off. Not that one, this one here. And at the bottom, I'm going to round that as well. Just until it looks okay. We don't need those sharp corners there. And we'll say OK. So the next part of this process is mounting. And there are a couple things that we need to consider. We can't directly make a plane off of this mesh unless we go into our mesh tools and we go to direct mesh edit. We can select the mesh body. We have to do it from the browser because we made it unselectable. And basically, once we're in here, we can create a plane from 3 points. So find the 3 points. If we've got a good scan reference, so for example, if we got a flat face there, then we'd be able to do it. Again, we would need to make sure that this is we need to turn off the deselection, the unselectable option, and we could build a plane that way. Another thing that we can do is we can just manually create a plane. So we'll create an offset plane from here and begin pulling this back. What I'm going to do is I'm going to resize this plane. And we can just kind of take a look at where it is and then make adjustments to it. So right now it's obviously not in the right spot. Kind of move it around and pull it back until it starts to go into that section. So you can tell on the screen, it's going to be maybe a little bit difficult for you, but you can tell on the screen when it starts to cut through that mesh. You can kind of see there. So this gives me a pretty good reference for where that plane is without having to go into mesh edit and create a plane off of points that could be off based on the orientation of the scan or the quality of that edge. So that looks pretty good. We can see that it's cutting through at those two spots. Now I can create a sketch. So right click, create a sketch. And we're going to do basically what we want to do is create a tab that goes all the way through. So a circle, we're going to place the circle at the right location. We're going to make a 6 millimeter hole and another circle. We'll make a 10 millimeter. Kind of pull this around, hold down Control. That way it doesn't snap to anything. And then I'm going to use my line tool and just kind of come out to the left, down, and back. We want to make sure that those lines are horizontal. I'm not going to worry, for the purpose of this video, I'm not going to worry about dimensioning everything. It is important, but in this case, I don't want to waste a bunch of time adding a ton of dimensions. So what I'm going to do is just extrude this, select the geometry. I want to keep these at least 3 millimeters, and we're going to create them as a new body. Say OK. And then I want to mirror it to the other side. Now you might be thinking to yourself, well, it's kind of sticking out. What are we going to do about that? Well, I've got a trick for that. We're going to take care of that. All right, so that looks pretty good. Then we can use this tool called Split Body. And we're going to use the outside of the headlight to split that section off. We're going to repeat it on the other side. So we're going to split this body. We're going to use the outside of the headlight. And what that does is it gives us these tiny little pieces. And then we can combine the rest of these together. So these two, we can right click and remove. And then we can use the combine tool to join the headlight, mask, and those two tabs. So now we got those two tabs added. We need to do a little bit more in terms of the mounts for the fork. But for right now, this is enough for us to mount the headlight to this headlight bucket. We would want to round the corners off and make sure everything's strong enough. But for right now, this is a good spot. The next thing that we need to do is we need to create the tab down here that this is going to screw into. So this theoretically should be on the mid plane of the design, assuming everything was centered. I'm going to use slice, and I'm going to create a circle that is roughly in the middle of this. This one, the way this works on the design, this is one that actually gets threaded into. So it needs to be the right size. I'm going to make it 5 millimeters. I can always drill it out if I need to. And then I'm going to make this one 10. And in this case, I'm going to come down. You can kind of see where the headlight is. So I don't want to come straight down because it's going to be outside of that. So I'm going to come down and forward and then back up. We'll make sure that these are tangent. Again, I'm skipping past the fully defined sketch part of this, but if you're making this design and everything lines up, I would strongly suggest at least locking down the center location of this. And now we can see that this is not centered, but that's okay. Because all we need to do is select offset. Let's see, -2 millimeters. That probably will get it. Looks like maybe -3. Let's do -3 millimeters. And then let's go ahead and make this a bit thicker. We'll say -4. New body. Actually, let's make it thicker than that, -5. And okay. And once again, we can use that split body trick. There are other ways to do this, but I find that in the concepting phase, especially when dealing with complex shapes, that this process, the split body, tends to work okay. Another option that you can do, and I'll just show you that real quick here, is we could have left all the tabs extending outside and we could use boundary fill. So then we select the solid bodies that we want, and then we select the cells that we want to keep. So we want to keep the major portion of the mask, we want to keep this little tab here, and then the section where they overlap. This can be created as a new body. We can also use the join option to join them together and say okay. And what we're going to be left with here is going to be a couple of things. So let me hide these so we can kind of take a look. So we're going to have this design here, which has that body added to it. So that little tab is clean on the outside. And then we're going to have that tab that's kind of left over. This one can be removed. We don't need it. So we can right click and remove it. And then we're left with the same design. So whether you use split body and remove or you use boundary fill, either option is going to be fine. Boundary fill can be helpful, especially with multiple tabs. You can do a bunch of them at the same time, and then it simplifies all the split bodies and removes that you have to go through. If it's just a couple, it's kind of hit or miss which one is going to be more efficient. You kind of just have to decide for yourself. From here, the final design that I'm using also has a hole in the bottom. Basically what I did was I just added a boss here and put a hole through the bottom. I'm not going to do that for this design because we don't really need to worry about it. But there are two more elements to this that we need. One is a rounded lip that I put on, partially for strength and partially just to smooth it off. So we're going to add that. And then the other is the tabs where it mounts to the fork. So the way that that was done, I'm going to go ahead and rotate this around, is basically we need to make a plane that is in roughly the right location. And what I mean by that is it's going to be just inside the fork here. And then we're going to use that plane to create a tab that attaches here. So with just the scan of the motorcycle, we're going to select the construction plane and grab a plane, start to pull it this way. And again, we can tell when it starts to go into the mesh if we resize it. You can kind of see there when we hover over it where it's cutting through. So then we're just going to pull it back so that it's inside of the fork. And then we're going to create a new sketch. I don't really need to see the motorcycle. All I really need is the solid body. We can use slice. And you can see that we're going to have a problem. And the problem we're going to have is that when we use slice, it completely cuts away the mask. Like the mask isn't there anymore. What that tells me is the mask is not wide enough for this to work in that area. So the tab is actually going to be, it's going to come jog its way in. So it changes things a little bit, but it's okay. So what we're going to do is from the side, I'm going to create a circle about where I want it to mount. Let's say right about here. It's going to be 16 millimeters, another circle, and we'll make that 25. And I'm going to go ahead and add some lines. And I'm going to hide the scan so we can see this. All right, so I want these lines to be tangent. This is going to be perpendicular. And essentially what we're going to do is we're going to build this little extruded tab, and then we're going to connect it to the rest of it by creating another extrude and jogging it over. So we're going to say, okay, extrude it. And we're going to come in. Everything else is 3 millimeters, so I'm going to stick with that 3 millimeters. And now what we need to do is find a way to get it over and inside. So now that we've got a reference here, we can create a new sketch on top. And we can carry this in and then back. So I'm going to do the same thing over here. In and then back. And then we can make sure that everything is the appropriate thickness. So I can say, you know, this one to this one, I want to make sure it's 3 millimeters. You can see that this is kind of narrow here. We may need to do some work to make that thicker, but hopefully this will just get the point across. So what we're going to do is take this and sweep it. I take that and sweep it along this edge. We want to join it together, but we don't want to join it to the headlight mask. So we're going to hide that and we're going to say, okay. And the reason for that is because now we can kind of see where it falls. We can make some adjustments. So all we need to do is we need to bring back our sketch. And because we have constraints, so the parallel constraint, all we really need to do is start dragging this until we're happy with its location. All right, so that looks okay. It's starting to cut through, but it's not a big deal. And if we need to, we can extend it this way so that it goes all the way through. And I think that looks okay. So we can hide the sketch. We can use our split body tool, just like we did before. Select the outside of the mask, and then this little piece here. Now it's given us an issue. Generally, when we get that, it's because of this overlap here. So once again, we could use things like boundary fill, but you would generally want to do that after you mirror. So we want to mirror this body to the other side. So we'll take that and mirror it across, and then try boundary fill. So select all three things that we want, and then select the center cell, all the little tabs that we want to keep. So basically the only thing that we're not keeping is that little bit of excess there. We'll say okay. So this should leave us with these little tabs attached. The last thing that you may want to do is sort of fill in the area between this and that for extra strength if you need it. For the 3D printing, I mean, it's going to print that okay. It won't really be a big deal. But what I did on my version is the mask is a little wider here, and I filled that in by just extruding from this face forward and then just kind of fill that stuff in. But what I want to do here is add a fillet. So F on the keyboard and make a large fillet here. Hold down Control, do it there as well. So on the internal edges. And then I'll do a smaller fillet on these edges here. Hold down Control to add to it. I'll just add one there too. So that's the general idea here. If you do want to add a rounded lip to the outside, then generally what you can do is create a new construction plane along an axis. So find a location that works. We'll create a sketch. And then you can create an arc, for example. So like if we wanted to do an arc that comes into the design and a line to close it off. Again, I'm shortcutting some dimensions here. But then what we can do is we can take that and we can sweep it. So sweep this profile along this edge. And typically you would do this before you added these little tabs here. But instead of cutting, we would join it together. And what this will do is this will give us this little rounded lip feature on the outside. Generally, you see that on injection molded parts that are about this sort of geometry because it adds a little bit of strength in the shape. So if you're trying to print this in like a PLA, for example, and not a pla-cf or PCTG or something like that, then this will help it not flex nearly as much, especially if you're trying to use it to create a mold. But for this one, I'm not going to leave it on there. But for the most part, you can do that, and it goes all the way around the design. Just adds a little nice rounded lip there. Last thing to do is just to make sure everything's strong enough. Maybe add some fillets around these bosses where they hit, so they don't break or anything like that. So you can just kind of go back through and add some fillets anywhere that these things hit, just to smooth it off. And then you can print it and try it out on your own. Now, obviously, I skipped I skipped around a little bit. I didn't put dimensions on things. But again, the number of people out there making a KTM headlight shroud for an 83 GPZ with a GSXR front end is zero. All right, it's just me. So there's no point in going through all the little nuances and details and things like that. But hopefully the idea behind this and the steps that we took along the way, some of the design decisions and things that we did for our form, some of that stuff hopefully is helpful, so that way you can understand the way that we go about this process. And as I mentioned, they're different, right? Like they're not going to be the same. The one that I made that's on the bike now is different in nature to the one that we just created. They're just, at the end of the day, they just have different shapes. One's not better than the other. They're just an exploration of a design. Now, this one has harder creases on the edge because on those bevels, I ended up pushing the crown a bit higher, whereas on the one that I ended up using, I made it a bit smoother. So I kept the creases just a little bit closer here, and I carried them on the side a bit more. But for the most part, you can see that it is the same process no matter which direction you go with the design. The last step from here would be to print it, obviously. So the way that I approach this is I save the mesh to my bamboo slicer, and then I need to really look at the way in which the part is going to be oriented on the printer and figure out what is going to be the best approach to printing this. Now, I'm a big fan of using tree supports, and I generally will go to tree supports when I can. They tend to print a little bit faster. And what I want to do with this design is look at the curvature. I'm not so concerned about the tabs and things that are hanging out. They're going to need supports no matter what we do. But look at the curvature and then figure out which orientation this is going to print best in. So when we think about 3D printing with like a desktop machine like this, the curvature in the XY direction, so basically in the plane of the build plate, is going to print well. It's going to print really nice. However, as we start to build curvature in the Z direction, so for example, like this down here, that's going to start to get pretty bad. So those are the areas where we really want to think about, okay, well, how do we want to print this? So if I were to rotate this design like, let's say that, it would require a ton of support. These would be okay without support, but everything else is going to need support. This part would print great, but as we rolled over the top, that part would not print very well. So the way that I've printed a couple of these now, the way that I would approach it is probably to print it in an orientation somewhat like this. This means that most of the design can remain unsupported. The curvature on the sides and these areas are going to print really well. And the main area that's going to give us problems is going to be this top, which is mostly a flat section. Now, because on the bike, that section is it's mostly hidden, it can be sanded and primed and prepped pretty well. And I'm not too concerned about that. The rest of the geometry is more visible, so that's what I would worry about. So I would go into my strength settings, increase the wall loops, go to my support settings. I'm going to enable tree support and then slice the plate and see what my final looks like. Now, the first one I printed, I put this bottom portion on the build plate and I didn't like the way that it printed. The second version, the one that's on the bike right now, I flipped over like this and I liked it printed better in that orientation. But again, it's going to depend on your geometry. It's going to depend on how you build these things. So you can see here there are a couple supports because these are completely overhanging, and then it builds this tree support to come up on the inside here and kind of fill all this stuff in. Now, as you think about this as well, you could go back to the design, and instead of this being such an overhang, we could round this off in the form and make it a bit smoother transition so no supports were needed there. But either way, this is going to be probably a good solution to the problem. We can see that this one here is going to take about 5 hours to print, which is a little bit less than the last ones I did. And it's just because it's smaller, the sides, there's less material there. But overall, at the end of the day, that's the process that we go through to design a custom part like this. Now, some of the key areas here, obviously we needed to be able to scan the headlight to make this work. Without being able to scan that headlight, this would be much more difficult. We could measure the tab locations in space. However, getting the shape of the headlight in 3D, understanding where we needed to move things in 3D would be much trickier. So having that option to have a 3D scan and to be able to use it to build a design, that is going to be big. It's going to be a huge help when dealing with these custom parts. And as I also mentioned, I used both the Metro X and the Morocco to scan the headlight. Both would have been completely usable. I ended up using the Metro X scan for the headlight because it was much cleaner. The Morocco needed a little bit more work to get the detail on near mode. On the front, I would have to just do some extra steps, but certainly possible. And I don't think at the end of the day that the quality of the scans for what we need here, I don't think one would win over the other. The Metro X did a great job, but again, I could have just as easily gone with the Morocco for everything that I needed here. So if you have any questions on this, I know this one was a bit long, but if you have any questions on this process, please let me know. If you want to see more, remember to subscribe. We're going to be releasing videos. I'm not sure which episode or which part we're going to do for the next episode. Probably the tail section will come next, but there are a couple extra bits and pieces that I need to think about for that. So it's going to either be the tail section, the speedometer, or maybe we jump in and tackle rear sets. I'm not quite sure yet, but when I know, you will know.
All right, so there we have it. That is the process of scanning and designing a headlight for our bike. This is something that you're likely to do multiple times, and it's good to be able to have some sort of reference. That might mean that you print some general shapes or you make some general shapes. You take a picture of whatever you're working on and you do some hand sketching or painting over it. Or if you've got the mind for it, to visualize it in 3D before you start. Now, the way that my kind of mind works is I can see this stuff a little bit in 3D in my head, but it's more about visualizing it on the screen and then in real life for me. that's one of the things that's kind of tricky, is everybody can kind of approach this differently. Some people can just see this stuff and know exactly what they want it to look like, but then have trouble translating or transitioning that into 3D modeling. With me, I can do the 3D modeling just fine, and that's generally where I do my shape exploration. I have an idea in my head what I want the shapes to look like, but it really doesn't come to life until I start it in 3D. So depending on how you approach problems like this, you may find yourself spending more time with pen and paper, making some shapes and kind of exploring those. You may find that you take a bunch of pictures from different angles, you visualize it, and maybe again do some painting on the computer over or what, general shapes. But at the end of the day, what I find to be the most helpful thing is coming up with just a couple of key shapes. And what I mean by that is, from the side, coming up with a curve and that wraps under. And then from the front, coming up with the transitions that match the headlight. And once I have just a couple of those key shapes down, then I can go exploring where I want hard edges or creases or make changes like that. For me, that helps the most. Again, everybody's a bit different, so it depends on how you visualize and work with this stuff. So if you have any questions on that process, or if you want to see more of this bike or anything we cover on this channel, think about subscribing, and definitely leave a comment below if it's something that you want to see. As we transition more in this bike, we still have to do the GPS speedo, we have to do the tail section, we have a lot of stuff that we probably won't cover in videos. I need to do some more wiring. We'll likely do a video on the exhaust. I need to get a TIG welder. I've only got a MIG welder here, and I don't really want to MIG weld an exhaust. So I'm gonna have to work through some of this stuff. We do also need to do some mechanical parts. So we've already done the triple clamp, but we've got rear sets that need to be done, which is a little tricky since I hacked the frame up quite a bit. So I saved some of the tabs that I cut off, but we're also gonna have to figure out some, some frame bracing and things like that have to happen. But there's still a lot to do. Some stuff will be covered in the series. The design stuff, obviously, we're gonna go over. Some stuff will just surprise and be done when it's done, because it's not gonna be very interesting. But as we go through this, if you do want to see that kind of content as well, doesn't fit so great with the channel, but if you wanna see or have me talk about some of the wiring or some of the mechanical stuff that we need to do to get this bike revived and back running and on the road, then let me know in the comments, and I'll be sure to include those maybe as a bonus video when we do the wrap up or something like that. I'll put all that stuff together. But again, any comments or questions, please let me know. As always, thanks for watching. We'll see you in the next one.